Alright, so in this clip we're going to start looking at the hair dynamics options that are available inside of our hair system. Now I have made a few changes in between these last two clips to our scene. The hair is still 100% identical, but what I did do is create a quick rig for the head so that we can have some animation on it. That way, as we test out the different physics settings, we'll kind of see a little bit better what the physics are doing. It'll be the hair kind of thrashing around as opposed to just falling flat down. So let me show you how that looks. All right, here we go. I'll just play this play blast. And you can see he just kind of throws his head around back and forth a little bit, just enough for us to get an idea of how the physics look. And we can see right now they don't look too bad. The one thing I will say looking at it is that they definitely are way too animated, meaning that they don't really come to a stop. They're just kind of jerking around quite a bit. They really need to be dampened. So let's see what we can do. Right now they feel like very heavy tendrils. They don't actually feel like hair, which would feel a bit lighter. Maybe wet hair, but not exactly maybe what we have in mind right now. So I'll go ahead and select my hair system, and let's start taking a look at some of these settings. And those are of course going to be found under dynamic properties. Now there are some things you can do under collisions here. For example, we can change the bounce, the friction and stickiness of the hair. So at the moment, though, I don't see a huge need for this. Right now, the bounce we definitely don't want anymore. It's already bouncing enough. And friction is already pretty high. I don't want to set it so high that it feels like it gets stuck to the face. So for the most part, we're pretty good here. Now, there is a setting down here called static clean. This kind of mimics the effect of static electricity. It's going to cause some hairs to stick together. And this can create some really cool results. Unfortunately, though, at the expense of some very slow simulation times. Now, it has increased in speed lately, but if you take a look, if I just hit play right now, you can see that no, we're not moving quickly, but I'm already at about 15 frames, and it's at least, it's doable. I'll go ahead and grab my hair system here, and let's try turning on some static clean. Go ahead and rewind. And you could see it's definitely chugging quite a bit more. It's probably simulating at less than half the speed it did before, but you could see that we're starting to get some interesting effects. You could see the hairs are actually kind of clumping together. It's that, again, effect of static electricity. Now, I did bring this setting up pretty high, which probably isn't exactly what I need. That's pretty intense right there. So let's go ahead and maybe drop this and do something like 0.2. Go ahead and rewind there. Let's hit play, and you can see it's still moving slow, but it's not terrible. Now we can still see the hair beginning to clump together a little bit, but not as much as before. So this is a great setting for naturalistic hair. Again, you just have to be careful with it. Number one, it can be a little bit too much too quick. You can see even right now it's starting to feel that way again, and it will slow down your simulations. I'm going to go ahead and keep mine fairly low. We'll do something like 0.05. Oops, not 2.5 or 0.25, but just 0.05. So just a little bit of that static. All right, and that brings us now down, let's close off collisions, to our dynamic properties. And the first properties we're going to look at are the stretch, compression, bend, twist resistances. So just as they sound, these are resistances, meaning that if I take these up, there's not going to be more stretch, there should be less stretch. So if you see your hair maybe feeling like it's elongating unnecessarily, especially when he whips his hair around a little bit too much, we can go ahead and up the resistance. In fact, I'll take this up to about maybe 90. So considerably higher. Compression resistance would be how likely it would be to crunch up on itself. Now, there's really nothing about this current simulation that would cause it to crunch up too much, with the exception of the times where he kind of whips his head around and the hair kind of gets caught up on top. Adding a bit of compression resistance will help that from getting clumped up there. So maybe I'll up that to 20. So let's go ahead and just with those two changes, let's do another play blast and see this result. All right, there we go. And we can see it's actually a pretty big improvement. In fact, you can see straight from the beginning, we now no longer have that weird effect where the hair seems to kind of drop down. And that's because we got rid of most of that stretch. We're resisting a lot of that stretch. We can also see that the hair is calming down a little bit sooner. And that's primarily because of two different things. It's going to be some of that static that's causing the hair to stick together and therefore not move about as independently. And that compression resistance is keeping it from getting crunched up too much, and therefore it relaxes a little bit sooner. However, it still is moving probably a bit too much. It feels like yarn hanging off of his head more so than hair right now. So we want it to calm down a little bit faster. So let's take a look at a few other settings that we have over here. Go ahead and bring this back. We also have bend and twist resistance. Now, a bend resistance is going to keep the hair from bending, and you can imagine that if this is set too high, then the hair effectively isn't going to move very much at all. So you could imagine that this one here would be good for things when we have actually some kind of product in the hair, or if the hair is maybe very short where it isn't going to deform very much because it's got a bit of stiffness to it. So maybe we'll add a little bit here. I'm going to go to maybe 3. You can also add a resistance for the hair to twist around itself. Our hairs aren't really doing that too much now, but I'll add a little bit of that resistance right there. Now, this last setting, not really the last, but this setting over here, the extra bend links, what this does is if our curves don't actually have enough points in them, it'll actually add additional data so that we get smoother curvature and bend, basically better physics. So you can always add that in. This does kick up our simulation time quite a bit though. Now, if you're finding even with this stretch resistance that you still have stretching, you can go ahead and turn on this option here called No Stretch. Now, I will warn you, I've not had this issue in Maya 2017, but in several past versions, just turning this on would immediately crash Maya. I think it was just a bug in maybe 2015 and 16. Again, been so far so good on this version here, but just be mindful, you may want to save before you use it. However, at the moment, my stretch resistance is doing it just fine. I have no need to turn that on. So with these extra settings turned on, the bend resistance, the twist, and the extra bend links, let's go ahead and give this one more play blast. All right, here we go. And take a look at what we have now. It looks better in some ways, but actually worse in others. The physics are moving a little bit nicer now. I like the collisions a bit more. However, notice that the hair feels a little bouncier than it actually did before. This probably has to do with me upping the bend resistance. Since I'm resisting the bend, it's making the hair stiffer, and because we're resisting, stiffness in the hair, it ends up being almost like a rubber band trying to go back to its position. So I'll probably go ahead and turn that back down. Go ahead back to my hair system here, and we'll just put our bend resistance rather than 3, maybe let's actually try 0.5, so actually very little. All right, now I'm going to skip by just for the moment over this rest length scale as well as the stiffness scale. We'll look at those in a future clip, but I am going to drop down here a little bit to these forces I want to briefly discuss. Now these are very obvious. They're stuff we've most likely worked with before. Mass is going to be how heavy the hair is, how dense the hair is. Drag, we have drag, tangential, and motion drag are all going to slow down our hair as it moves through the air. We have damping, which is going to kill off motion over time. Stretch damping, which will kill off motion in stretching of the hair. We're pretty good there right now. And think of the dynamic weight as almost a slider or a percentage of how much dynamics we're going to have on the hair. Turning the weight down low, it's not going to react very much to dynamic stimuli. You can also ignore the solver gravity. That's the gravity built into the nucleus. Same with the wind over here. That way you could always make use of these other ones over here. Let me find them here, fields, such as these. These are our old solvers there, or excuse me, our old fields. So I'm going to make a quick change here. I'm going to turn up my damping to about 0.2, and let's do one last play blast. All right, so here's our result, and it's looking really good. You can see that the hair is much more relaxed now. While it still kind of, dangles around a little bit, it's really calmed down significantly, and I really like what we have so far. So there are, though, some more dynamic settings I want to cover, but let's save those for the next clip. So I'll see you all there.